Hi, I'm Tene. I'm the CTO of Azul Systems, which you would know if the text wasn't censored. And I do a lot of Java speaking. The subject we're going to cover today, that's the actual title on your program, Keeping Up with Java, look at all the new features. We have a few different titles we use for these subjects. So here's another one, from JDK to 13 and beyond. Another one I like to use is Java after 8, or Java after 8. Yeah, I know you're gonna go get some mints afterwards, right? But let's do a quick informal poll. How many people here are running Java 6 right now in production? I feel for you. Okay, good, yeah. How about Java 7? Raise them high. Okay, that's a few more. What about Java 8? Ooh, look around. Good. Okay, so that's kind of what I expected. How about Java 9 in production? Look around. Well, that's probably healthy because it stopped being updated a year ago. What about Java 10 in production? Now the big one. What about Java 11 in production? So look around. We have a bunch of good, courageous people that have gone forward and started beating up the platform for the rest of you. I'm hoping that a year from now, in a similar poll, we'll have a lot more hands up on Java 11. Now let's go beyond 11. Who here is running Java 12 in production? 1, 2, 2. How about Java 13? Up, up. I am, yeah. Okay, this is a very common poll kind of result that I see in most Java audiences. It is worthwhile for you guys to look around and see what things are. There has been a progression of the Java 11 people, because 6 months ago there were very few of them that would say in production, right? If we said playing around with it, it'd be different. And really what we're going to talk about here is Java after 8, right? All of you, almost everybody here said Java 8 in production. And we pretty much know where you want to be in 3 years, which is not Java 8 in production. So this is kind of a taste for what's on the way, what are the considerations, what kind of things you want to do. Now, we only have about an hour, so I'm going to touch on a few things along the road, along the way. And there's a lot of detail you can find, both from presentations we've done online. One of my colleagues, Simon Ritter, does these 55 new features in Java 9, 55 new features in Java 10. So if you really want the details, we'll find them there. But generally, we're looking at a progression in Java that is new. It's never happened at this pace before from a numbering perspective. And a lot of times it confuses people because they're not sure, are you supposed to move that fast, not supposed to move that fast? Are you supposed to move fast but then stop for a little while and then move fast? So let's look at history a little bit. Java 6 is now about 13 years old. So those guys that still had their hands up, I understand why you still do it, and I hope you find a way off of it soon. Java 11 is now 10 years, well, not 10, but 8 years old from that point, right? Sorry, Java 7, did I say 11? No, Java 7. Java 8 came out just over 5 years ago. And look at how well adopted it was. I mean, you guys are, almost everybody here is on it. And then we had Java 9. Now, Java 9 is sort of a last point, first point transition. And we're going to talk about that a little bit. A lot changed in Java 9. And that happened just 2 years ago. Can you imagine that Java 9 is 2 years ago? Not that long ago? Since then, we've had Java 10, Java 11, Java 12, Java 13. And we're about to have Java 14 in 5 months, okay? So there's a pace going on here. And a lot of times people try to figure out, where am I supposed to fit in this? What am I supposed to do and run? Yeah, there's all this cool stuff, but should I use it? Should I not use it? How should I use it? What flags should I use with it? And we're going to touch on a few of those. So the roadmap for Java releases since Java 8 and 9 is kind of here. This is based on Oracle information. published a couple years ago. And the important thing to note here is, see those long lines? Those are called LTS, or long-term support releases. Those are versions that were sort of designated by Oracle and acknowledged by others as these are going to stick around for a while, long-term support. If you want a context for that, every version of Java up to and including Java 8 was long-term support. So what you're used to is long-term support. It's here, it's going to stick around for a while, there's years before it'll go away, and yeah, there's some new versions coming. All the other versions in the middle are not long-term support. You can call them all kinds of things. You could call them short-term support if you want. They're called feature releases in some terminologies. But the important thing about them is they live for 6 months. Meaning there's a new release. For 6 months, there's updates to that release. And after 6 months, there's no more updates for that release. You basically either go forward or go back, but don't stay on that one. Java 12 has had its last update ever. There's nobody I know of, not Oracle, nobody in the OpenJDK community, no company supporting it, that intends to do a Java 12.03 update. There will be no Java 12.03. It's a dead end. Now you can move on to Java 13, or you can look for a vehicle that lasts long if you don't want to keep moving every 6 months. But you should be aware of this map. As we look at it, we are right there right now. So we're in the middle of some nice, cool feature releases. We're going to see cool features in them. You can play with those features on your laptops. You should. You should get ready for them. You should make sure your software runs on them. And then you need to make choices. Do you go to production with them and work that treadmill? Or do you wait until the next LTS before you start using the features in actual production code? That will probably significantly affect how you choose to use the language features. Okay, so we want to come up to speed for what happens after 8. The current Java for you is probably either 13 or 11, depending on who you talk to and depending on whether you're willing to run the treadmill every 6 months or you want something stable for 3 years, then switch to something stable after that. And to understand what's in those releases, you basically have to look at all the releases before from where you are today, since pretty much all of you said Java 8, see, I guessed right. You need to understand Java 9, 10, 11, 12, and 13 to figure out where you are right now. It's not enough to go look at, see, what's new in Java 13, because there's like 3 things new. You need to look at the whole history. And that history comes in multiple forms of change. So I'm going to comment on these as we go, and I don't want to go redefine it every time. We're going to see changes to the Java language itself. So when I say Java 13, I might mean the language or something else. But the language is the syntax. It's how we express and mean code, but it's not the APIs, it's not the libraries, it's not what's in the platform. There are changes to the Java syntax. How many of you know that Java 9 had an actual Java language change? It's very small. The underscore identifier is now reserved. That's a change to the Java language, because if you have a variable called underscore, you've got a problem. Before it was allowed, right? But there are bigger changes in later releases, like cool, switch statements we'll go over. Java SE is the platform. And when we say Java 13 or JDK 13 or Java SE 13 or any other number, we're talking about an actual specification of the Java SE platform. One of my roles is I sit on the JCP executive committee where we actually vote on these JSRs and approve them, and when you get a new release, there's a new one of these every 6 months now. So there's a new spec. That spec has whatever the new language features are, but also whatever new APIs there might be or whatever APIs were dropped. It defines the platform. We've had specs for Java now for 20-some years. It's probably why Java is as successful as it is as a language and has been around so long. And then we have OpenJDK. And it's important not to confuse the OpenJDK with Java SE. OpenJDK is the reference implementation for Java SE. It's probably the basis for most of the implementations you will be using in one form or another, including the Oracle JDK, which is based on OpenJDK. But OpenJDK has things in it that are not necessarily Java SE specified. So for example, how a garbage collection works. It needs to work, but what exactly the flags are and what its features and how fast or pausey it is, that's got nothing to do with Java SE specs. Whether you have class data sharing or not. Those are internal under the hood things. And as you look at what is new in various releases, you'll see lists of things that are new in a language, things that are new in the spec, meaning new libraries, other APIs, and some things, a lot of things often, that are under the hood, may not affect how you program, may not even affect how you work or do stuff, but they're interesting features that the JVM in OpenJDK is adopting and maybe other implementations are not. So those are 3 different categories. So let's start with one of the big ones. Java 9 was the last really big release. Really big. There's 86 JEPs in there. I think that's 86. And it included changes in all the categories we just talked about. So for example, if you take a look down here with my magic wand, there's a port to Linux S390, right? So you know, that's an OpenJDK detail, right? Java didn't need to know about mainframe computers. We didn't change anything. It just was ported to it. But we also have things like UTF-8 property files and Unicode. Those are actual meaning, right? You can now expect certain behaviors from that Java version, whatever Java you're running on. And a lot of other features around libraries and APIs. So many, many changes. Let's get probably the most commonly talked about or big one that people talk about, the new module system. Starting with Java 9, we have a module system. The JDK itself is modularized. You can find the detail under JEP 220. And it has 75 different modules inside the JDK. The way these are broken down is 24 of them are Java SE, the platform. There are 48 that are JDK, which is not Java SE, but the platform, but might be various forms of internal implementation parts. Not necessarily something you can expect in every Java platform, maybe not in another future OpenJDK because it's internal. And then we have these 2 aggregating models, Java SE and Java SE EE, that was introduced. And I'll skip the smart card thing. Most of the internal APIs are now encapsulated in one form or another in the various JDK modules. That includes things like sunmisconsafe, which really threw people into a frenzy right before Java 9 came out. And this is actually one of these rare occasions when the JCP, we actually pressured and delayed a vote and asked for fixes before a spec was modified. Because in Java 9, there were command line flags and additions added so that people could, even though this is sort of hidden for good measure for the long run, you can put flags on to still use it. Because without it, 99% of the world would break. Now only 70% of the world breaks, so better. But these are major changes. The encapsulation is there for the JDK itself, and the JDK is fully modular. The module system is also available for you to use. You can keep using a class path model like you are used to, but you can also put your code into module form. And the modules have a lot of nice, healthy benefits for doing them. Another important detail is you can actually put modules around code without forcing you into a Java 8, post-Java 8 world, because you could put a module info file around, but not use any module features within your code. And that means you could take your Java 8 and make it module ready. A cool feature that came along with this is Jlink. Jlink is a Java linker that allows you to say, okay, I have my application, I have my JDK, I would like to make something, an image-like thing that is a JDK with my application in it and nothing else. And what it will do is it'll find the modules you actually use, you actually depend on, and put only those in the image, not carrying the entire platform because the platform is fat. It's important to understand that it will bring in modules in their entirety. There's no half measure, there's no one class, one method kind of stuff. A module is a module, it either is in or not. And when you do this, your image will end up with kind of whatever it is you actually use, you will always find java.base in your modules. Probably obvious why. But then the other things are depending on whether you used any features in them. Okay, so Jlink lets you do this linking. How do people use it? We're still trying to figure that out. Whether people will use it en masse to package their stuff and deploy that way, or just deploy the old way. Most of what I see is still the traditional way. Most of what I see doesn't even have modules in it yet, even on 11. But as people put modules, it looks like a module path is the more common way to deploy right now than Jlink. Jlink does have some nice features in that you can use it just to make sure you're not using things you're not supposed to. You could limit the footprint, you could limit the code that's being distributed, all kinds of reasons, you know. Who here uses Alpine Linux for various reasons? Okay, so the same reasons. If the code isn't there, it can't hurt you, that kind of reason. Okay, now with Java 9, a major change in how Java thinks about continuity happened. And this is a controversial change. We're still in the midst of it, and we're still figuring out how hard or bad or good or wrong or whatever it is. But as we go through adoption of post-Java 8, we're going to see the impact of this, and hopefully it'll succeed and we'll all move forward. And if not, there are ways to fix this. So we're in the middle of a pretty controversial change. Two things happen big time that have never happened before. The first one is, you know all those deprecated things that you always get these warnings that say, you shouldn't use that, but they're still there, right? They've been there for 20-some years. Well, now some of them are gone. You should have listened, okay? So can't really complain, right? I mean, it's been telling you for 10 years not to use, you know, thread dot, you know, terminate, whatever, not interrupt the thread dot stop, right? Don't do thread dot stop, it doesn't really work. Well, now, you know, it might be gone. So these were removed. But a much bigger change happened because entire parts of the Java SE platform, not deprecated ones, not internal ones, not secret ones you weren't supposed to use, but well-specified ones that were part of the platform before, have been removed in Java 9 and on. And this removal will continue past Java 9 into future Javas. This is not the last time you will see this. At the very least, one important thing is that did try and happen wholesale in Java 9 as much as possible, with sort of a hidden part of the module. Like the entire Java SEE module is there, but it's hidden, meaning you have to actually add a flag to use it. And in Java 11, it was really taken away. It's gone. If you have JAX-B code in your application, there is no JAX-B in the JDK anymore. Good news is it is on Maven Central. So you can find it, but your code as is, with its dependencies where they are, will not just run because now they're missing parts of the JDK. You have to do something, usually in your build system, maybe a little bit in your code just to transition. Now, there are more features that are going to be removed in the future, and also features under the hood that are not platform features, but things like old garbage collectors, or maybe not so old, but you know, hard to maintain garbage collectors and other features. So those are lists. Now, an important thing is about compatibility is here's a statement that was made very clearly. Clean applications that just depend on java.se should just work. That sounds great, doesn't it? Well, I'd look carefully at how java.se is spelled. Okay. Java.se refers to a module in Java 9. So if in the future your applications just depend on the java.se module, this intent, this declaration of intent, is a good one you should probably count on for several years. However, Java SE with uppercase SE, 8 and below parts are absolutely being removed. As I said, all of JAX-B is gone. In fact, here's the various parts of the Java SEE module that are gone. Does anybody here use any of those? Does anybody here use them indirectly? Okay. Is there some Maven Central library you depend on that needs them? Okay, so I see the hesitation or the yeses. Let me ask it this way. Has anybody here ever used a base 64 encoded string? Do you use JSON? Because it uses base 64 encoded strings. So probably yes. And prior to Java 8, the only specified way to parse a base 64 string or to encode or decode it in Java, not using a third-party library, not using a secret internal thing, was in JAX-B. And it's gone. Now, Java 8 added a java.util.base64 class. So starting with 8, you can write it to something that isn't going away. But if your code was on 7 and just worked on 8, well, this is the breaking point. I'd personally run into this in several libraries. And if you use JSON, you probably will have to update your JSON parser. Right? But the good news is most of them have had a few years now to get ready, and most of them are in good shape, hopefully. Okay, so compatibility isn't guaranteed. That is big news. This was not the history we're used to with Java, but we are seeming to see the ecosystem sort of creep forward and adjust. We've had a lot of contributions, both from libraries at the bottom and from big application areas at the top. Ones to call out is Spring. Spring pretty much works completely on Java 11 and beyond, and it's carried everything it depends with it. So we're here in Spring platform, right? And the SpringOne conference. So presumably a bunch of you use Spring, and Spring is in actually pretty good shape. But the Maven Central dependencies that you can bring into Spring, not so much, not necessarily. And it's enough for you to have one dependency that doesn't carry over to mean that you can't carry over. You need to do something. Okay, so that was the big thing with Java 9. There is a lot more detail we won't cover here. As I said, you can find a lot of detail online, both presentations that I've done, Simon's done, and other presentations from Oracle and others. So JDK 10, the one after 9, what happened there? So JDK 10 was a 6-month update, right? The first actual feature release, and it really kept to the notion that we won't do too much in one release, because every 6 months you get something with a few features. I'm going to look at a couple of interesting features, and then we'll summarize. One of the big things that came with Java 10 is a new language feature. We can now spell var in Java. Well, we could also always spell it, but now you can't spell it the old way anymore. Right? Var is basically the same kind of var that you would expect from other environments and languages. It doesn't mean a constant, because it's var. It infers the type from the right-hand side of the statement, and it does a pretty good job of inferring it. You can think of it as mostly syntactic sugar. It helps you write shorter code, so you don't have to say the same thing twice in the same line. Some people love it, some people can't stand it. You get to choose. Okay? So you can use var in declarations of variables. You can use it, for example, in for loops. You can use it this way in a for loop, although arguably that's 3 letters, and you can spell them V-A-R or I-N-T, you know. Like, to me, INT here would be a lot more readable, because otherwise my brain needs to do inference on the constants, right? And, you know, because see, it doesn't say int anywhere else, right? But it does make things more concise. And here's a good example of where it makes it a lot less, you know, wordy to read. This is an example of what I think is a typical try with resources situation. Try with resources, a feature we got, I think, in Java 7, is a really useful one, where at the end of the try block closes whatever the closables are. And you typically end up declaring your stuff this way. It's kind of cluttered. With var, you get to do less on the left-hand side, and maybe you'll fit them into one line. There's a little cheating done here. But it's just more readable. Okay, nothing specifically to try, but you can use var inside the try with resources structure. Now, it's important to understand that var is a reserved type and not a keyword. You can do this, as we said, but you cannot do that. The reason that's important is you used to be able to do that. So if you happen to have a class that was really badly named, you know, VAR with lowercase v, then, okay. So this is an example where it was legal. It was very unconventional, but legal. Now it's not allowed, okay? I really don't, I hope not a lot of people get burned by this one, right? They deserve it if they do. Okay, okay, so that was var. Here's some other JEPs. By the way, a JEP is an OpenJDK term. It stands for Java Enhancement Proposal, which means sometimes they don't happen. Then certain JEPs are developed, eventually finished, and adopted in whole into JDK, OpenJDK releases. So if you look on the OpenJDK site, you can find for every release what specific JEPs are in it. As I said, 9 had 86 of them. 10 had more than this, but they're usually in the 10 to 20 level right now, so not too much. And I'll highlight a few things here. We just talked about local variable type inference, the var keyword, right? If we look at these from a point of view of what affects your coding, how you actually do your work, well, local variable type inference. Because the next one is some improvement to a garbage collector. And the one after that is an improvement to startup time behavior with class data sharing, which is a really cool feature. And then we have a new experimental JIT compiler. Experimental is a keyword, but it's there if you want to use it. And we have all kinds of cool ideas for how to use very large memories in there, and thread local handshakes, which is a really low under the hood feature in the JDK that lets us do safe points better. None of these, except for the first one, will affect anything in how you write code. Okay, so when you look at all these JEPs, as I said, there are categories here. There's the Java language, there's the APIs and the libraries, and then there's, these things that are just a better implementation of a reference implementation JVM. It's just faster, better, nicer, cooler, but doesn't change the code. Okay, let's look at some of these APIs. We talked about the language feature. On the API stuff, we have various nice wrappers for collections that make it easier to write collections around collections, and especially to declare collections of constants. It's less cumbersome to now create a list of something, and to copy them around. Between 9 and 10, we got quite a few of that. We have collections and conversions to unmodifiable collections, which is good discipline when you want to declare that from this point on, the collection you're handing over is truly immutable. In the future, this will actually mean performance. So when you actually declare that things are unmodifiable, at some point, the JIT compilers will be able to actually deal with that and actually be able to know that things are final and constant and propagate and maybe run faster than not. So if you know you've got an immutable collection, an unmodifiable collection, it's good to do that. And the reason it's hard to say collections are immutable per se is how'd you get anything in there, right? So they're mutable until they're not, which is what the unmodifiable part is. We now also have a way to spell optional or else throw. And for those of you with a keen eye for specification, you might notice that the actual definition of optional.or else throw is actually exactly the same as optional.get. It's just a different spelling. So we actually asked around to figure out, so why? Well, why is this there? And if you think about it, it sort of makes sense. If you are using optional, it's because you want to have your code be very readable for intent, right? This is optional, any reference is technically optional, right? But you're spelling it out. Similarly, if you say optional.get, it's not obvious that that might throw an exception, right? But if you say or else throw, the reader will know. So this is more about being able to spell things in a more readable form for things like immutability or lack of nullability, etc. Okay, so those are some hand-picked Java 10 things. Just a quick time check, good. JDK 11. JDK 11 is actually the first long-term support release after Java 8. In my opinion, a big reason there was not that much adoption for 9 and 10, beyond the hardships of moving the code there, is that everybody knew they were going to live for 6 months and then go away and live for 6 months and go away. And Java 11 was right around the corner, so why not wait? Java 17, which is the next LTS, is still a couple of years away, and then it'll take time to stabilize. So Java 11 is here. You can use it. It's an LTS release. It's not going away. So that, including the 10 and 9 in it, are probably the ones you want to look at for what does Java 11 look like. In addition to what we talked about before, we have some cool features here. Extended local variable syntax. You can take something that looks like that and spell it like that. You could put a var in a lambda variable declaration. Now, that looks like a weird detail. Why would I want to do that? Doesn't it read much better before? Well, when you do that, you can also do this. Because without the variable declaration part, there was no way to put an annotation on it. And again, going back to readability and cleanliness, if you want to declare things, not null, or any other annotation you might care about, then being able to stick the var keyword in there allows you to do that without much overhead in spelling. Okay. I actually think we're going to see a lot of code with this style as a result of this, because it will actually encourage people to properly annotate their lambda variables. This is a really cool feature. You can actually now run Java directly on source. And I mean run, not compile, right? So you can take a file, you can write, a class with a main in it and just directly run it without the intermediate step of Java-C. So that's cool, and you might look at it and say, okay, it's shorthand. Most of you probably use an IDE. And here's a cool way to use that I actually wasn't aware of until recently. Because of this, you can actually now stick JVMs directly in shebanging shell scripts. And that syntax up there, this part, is very important. You have to put the -- source part or it won't work. Or at least for now, that's true. So you can spell out the source is 11, the source is 12 or 13. You can't spell less than 11 because this is an 11 feature, I believe. I don't think you can spell source 8, but if your script literally is written this way and you just run it, it will launch the JVM and eat up the source and run it. So now we can have Java shell scripts, which is kind of cool. It's a little bit of overhead here to start a JVM just to run a shell script, but hey, we live with a world with a lot of compute power in it. Okay. Some other selected JEPs here. There are about 18 or 20 of them, so I won't go into all of them, but these are some high-level interesting ones. The first couple, nest-based access control and dynamic class file constants, are actually very significant changes to the specification of the JVM, not to the language, to the JVM spec, but things that you will probably never ever run into personally, unless you produce bytecode or you write ByteBuddy or things like that. You're probably not going to be impacted by those, but they do make life a whole lot easier for people who do. So they're useful internal under-the-hood features that really help not just the JDK, but people who run interesting things on top of them. The next two are things that affect you. There's an HTTP client, finally, in the JDK. Can you imagine? Wow. 2018, we got an HTTP client API. I mean, we had many of them. They were all out there. Everybody uses them. You use one every day. But now there's one specified, which hopefully creates some consolidation. Yes? The question was a reference implementation based on an open source product. I actually don't know the answer. I believe it was. I think it would be a waste not to, but I'm actually not absolutely sure about that. And if you look at the history of Java, a lot of the platform came from adopting just existing open source things into the JDK, where by doing that, we specified them, everybody can expect them, and we no longer need 17 implementations on them, because there's You could still have the other implementations, but there's one everybody can rely on working. That's how JAX-B came to be, but then we get rid of it. JAX-B mostly came from Apache code. And there are lots of other parts like that. Transport layer security, TLS 1.3 is supported in Java. It was only actually fully standardized about 8 months before the release of Java 11, so that was pretty quick. And this is probably one of the main features. I hear people say they want to move to 11 because there's external need for TLS 1.3, as an example. Not a language feature, but a platform capability. It has APIs, it has certain things you can program to that are new, but it also just transparently works. So, it's not that you need to change your code to use TLS 1.3. It'll auto-negotiate TLS 1.3. If you want to use some of the specific ciphers and force them, then you have to say so. Then we have, so these middle two are, they affect you, right? They're new things that you can use. And then we have a couple of under-the-hood features. These two are actual garbage collector features. One is there's a new experimental, highlight experimental, low latency garbage collector in OpenJDK. It's new. It's a beyond G1 thing. It's being developed aggressively and by some good people, and you can track the progress of it across 11, 12, 13. Presumably, at some point, this will stop being experimental, and you might actually be able to use it in some version of OpenJDK. But it's basically focused on low latency, no or very little pause at all, and that's an area I personally know a lot about because I actually created the algorithm this thing uses. In our products about 14 years ago. But you can read a lot online about the algorithms out there. The next one is the Epsilon garbage collector. And Epsilon garbage collector is a really cool garbage collector. It's a garbage collector that doesn't collect. So the interesting thing is you start off with what is this for? The actual original motivation for Epsilon garbage collection, and various people who build JVMs like we do at Azul, we always have these modes. You have a way to turn the collector off so you can measure how much the collector hurts. It's a performance measuring, it's an isolation thing. So you turn it off, you take out all the barriers, all the overheads, all the things the JIT compiler needs to know about it, and you run without it, then you compare the performance with and without, and when you design the collectors and work on them, you're trying to make that delta minimal. So being able to measure without the GC's effects is important. That mode basically runs for a little while, because its reaction to you've filled up the heap is out of memory exit. There is no way to get the memory back. There is no garbage collection, right? So you can't really run a normal Java program very long in this. But if you are one of those people who write, zero GC applications for Wall Street trading, then you might actually be able to run with this for a whole day because you don't allocate anything or you've object pooled everything or something. So it does have some very limited real-world, long-lived application benefits. It also could be useful when you run something for 10 seconds from a shell script. Why not? But like I said, the main motivation is it gives us a baseline of what it looks like to run with no GC so we can measure the overhead of the various GCs compared to that baseline. It's in there. If you guys want to play with it, go ahead. I'd be very interested in a poll of how many seconds you've been able to run Spring before it exited with an Epsilon GC. Yeah. Okay. So that was the JEPs, some APIs. So we have some cool things around I/O methods. Notice the common null there. So we can now have null input streams and null output streams and null readers and writers. What are null things good for? Well, when you compose a bunch of things around streams, it turns out that having null things is useful. Just like in Linux, we have dev null, right? Okay, I've got some output, but I really don't need it. Just send it there, right? That's the equivalent, right? Just it's a bit bucket with no end to it, and take out the overhead, and maybe it could be optimized out. That's on the output side. On the input side, you might ask, what is the use of a string that gives me absolutely nothing? It's got 0 bytes in it, and it'll always say it's in the file. What is this good for? Well, again, it turns out that especially when we start weaving things with streams, you might have things that are good at taking 2 streams and putting them together, but you only have 1 stream. So you give it a null stream for the other one, and it puts your one thing together, right? Because you want the functionality of it for some other reason. So there are places where, dev null input, dev null output makes sense. These fit in perfectly well within that. We can now spell is empty for optional. It's one of these. You had the opposite. It's a symmetry thing. So, little things come together, and this is really where the real value of all these libraries, if you actually go and dig at the actual benefit that's been going on under the hood, it's a lot of things like these that are not earth-shattering, but overall creating a better, more robust, more stable thing. Similarly to that, string has a bunch of new things that people have wanted for various reasons. None of these are critical, but some are very convenient. You can, figure out if a string is blank without some weird dot equals thing. Readability, right? You can break a stream into lines. You can ask it to repeat n times. You can now strip it in various ways. And you might notice that string already had a trim method. So what's the difference? Well, the difference here is that trim actually has a very narrow definition of what a white space is. Spaces, tabs, etc. Strip actually does the full Unicode. All the various international ways of having a white space are included. So this is the more healthy, more robust way to do what trim used to do in a truly portable, universal way. Okay. New APIs beyond that. We have a way to do a predicate, not predicate. And this is, again, a matter of taste. How would you use this? Because you can write this today, right? And for some people, this is very readable. I'm one of them. But some people look at that and have an arrow and a bang and all that stuff. And that doesn't just scream out that this is the not. You can instead spell it this way. And for those of you who like to make their stuff more readable, you can actually do a static import of predicate not and then spell it this way, which to the reader is arguably a lot more understandable than the second line up there with the not and the bang and stuff. So again, sort of a completeness for logic, it's in there. And this is where these modules were actually removed. Remember, I said in Java 9 they were hidden. They're kind of, hey, it's coming, a year from now they'll go away, you can still turn them on with the flag. In Java 11, you cannot turn them on with a flag. You have to go find them somewhere else, change your dependencies, change the way you build. Your existing jar files won't just work. Okay, so that was 11. 11 is just a year ago, right? So we've got 2 more to go. And then some other stuff to chat about. So JDK 12, again, we're not looking at any huge earth-shattering things, but there is a really cool new thing in JDK 12 in that it is the first version where we are seeing a preview feature in the JDK. So the ability to deal with previews is a new thing, and a thing you need to get used to a little in your thinking. So it has some really cool stuff. It's actually really, really nice syntax that you can use, but it's preview. What preview means is it's actually not in the spec. It might disappear tomorrow. Don't write using this and then come back and complain that it doesn't do it anymore. It told you right there. And the way you know it told you right there is it won't run unless you say this. So you can't complain and claim you didn't know, right? Unless you at runtime say enable preview, can't do it. We'll see, hopefully, a bunch of these coming out because the whole logic in this 6-month cycle is we can put out a preview. You guys can play with it. We can get feedback. We can change it because it's okay to break it because it's a preview. We can evolve it, change the spelling, change the syntax, drop the feature, whatever it is because it was wrong. And then after a few releases, we'll actually get stable. It'll move out of preview mode. So this is a really good example of an evolution of one. The idea here is that switch constructs in the old C style are kind of cumbersome. It's a statement, but it's kind of clunky. And you typically end up with code that looks like this. This is a good example of, how many letters in a day of a week. Hopefully all of you remember how to code this. Hopefully you don't have super high needs for it, but you got to put the break there or it'll fall through, and you got to remember to put a default statement and all that, right? What you really want to be able to do, and you can do now in Java 12, is to do this kind of stuff. So I can have, remember this is a statement, so it has a value. And what this is doing is determining what the value that the switch will return. This doesn't do anything other than return the value when you're writing it with this syntax. So here we can say specifically which groups have which. The presumption in that syntax is there is a break at every point. And the default does the obvious default thing, right? So the thing is, what if you want to do a little more than that? If you want to expand and mix the two modes, well, here's syntax that gives you equivalent behavior. So you can now have a break 6, break 7, break 8, break something that determines basically what the value of the overall switch statement is. What that means is you can actually put other lines before that break, do whatever other behavior you were planning to do. It's kind of like a complicated lambda if you want to do there and run that way. So this is in there in Java 12. We'll come back to it in a little while. The other part is you can do switch expressions this way with full code blocks. So rather than just the value, you can put in an entire block and then put a break with a value at the very end of that block to have the return, the value of the block come out. Okay, some other JEPs here. Shenandoah GC. Notice this pattern of new GCs? That's the third new GC. That's not G1. So the Shenandoah GC is a new, again, experimental GC that actually was contributed by Red Hat. First GC in OpenJDK built outside of Oracle. Actually, I think the epsilon was technically one way or another because the guy who built it used to work at Oracle, then moved to Red Hat, so I'm not sure what side of the line he wrote it on. Then G1 GC has some updates, so the collector is getting better. And these are just under the hood, are better at the collection, hopefully fewer corner cases that it runs into trouble on, and more elasticity for containers, that kind of stuff. We have a constant API, that's nice, and the default CDS archive, that's actually a pretty big deal. One of the focus points in JDK 12 has been on improving startup time, reducing the CPU spend and the elapsed time spent when you do Java Hello World. And there's been a dramatic improvement in the default behavior for that. A part of it has to do with the fact that the JDK now has a feature called class data sharing that's been around for a long time. There's also an app class data sharing that's been included since 11. And in 12, there's default CDS, so you can actually have sort of acceleration for loading the classes of the JDK in place, so you can start up faster. What that turns into is, that thing with the shell script, it makes it more sane. It also means that short-lived containers and other things makes Java more competitive with, say, JavaScript, Python, and others. It's still heavy, but only half as heavy. Okay, on the stream stuff, we have some new features like being able to do collectors and teeing, like a joining of streams together with bifunctions. I don't want to get into the deep detail of this, but I highly recommend you look at them. This also gives you a good feel for where there's null streams are useful. Right? Like when you have one of these, but you really need only one of the sides. And this is an example of actually teeing stuff. So we're taking a stream of integers, and we're basically computing the average. The way we compute the average is we have one stream that is basically summing up the numbers and another stream that is counting the numbers, and then we take the output of those two streams and divide them by each other, and that's our average. That's a nice, complicated way to express an average. Now, yeah, it's a complicated way to express an average, but remember the stream could be parallelized, and that input stream could have a terabyte in it. And now this becomes interesting on a fork join thread pool to express it that way, because that other not so complicated way to do an average, well, try to go parallelize that easily, right? So from an expressibility point of view, this is actually really useful. Okay. JDK 13. JDK 13 came out about 3 weeks ago. So we're current, right? Two main features in JDK 13 that affect your programming. One of them is text blocks. Again, sort of bringing Java to the current decade. You know, all those kids that like to write text without all those break lines and stuff, and, you know, well, we need to join them and attract them and all that. So you can now write that, and it's both, you know, multi-line, all the indentation is in place. It also is smart enough to know where the indentation starts. The output actually looks like this. So you can see the alignment there on the left. So that's there, it works. Note that, from my understanding, there's still a few kind of ifs and buts about semantics here, or whether these are the exact semantics they want, or they want to add a few other hints. They're corner cases on what do things mean when you break lines, and what characters go where, and how to do stuff. But for the common, obvious places, it seems to work really well, which is exactly these cases, right? So think of what that looked like before. You know, the amount of alignment you need to do in the editor, and then every time you write in the line in the IDE auto indents for you, you scream, and you know. Okay. So that was text blocks. And then switch expressions. Remember, we just talked about switch expressions and how they're a preview mode, and that don't complain if your code stops working because maybe things will change. Well, things changed. This is how you spelled things in Java 12. This is how you spell the same thing in Java 13, and the old spelling doesn't work anymore. So this is kind of to get you trained on what preview really means. I think maybe this was intentional. You know, just let's give them one, and then 6 months later we'll make it change so they know. You know, we really mean it. This is preview does not mean @deprecated. Okay, you guys have been spoiled for 20 years. Yeah, they'll never take it away. Now we're going to take it away all the time. Okay, so there you go. Okay, so you just change the spelling for yield, but this syntax is still the same. Okay, in the common case, you usually don't use that wording anyway. But now, instead of break, it's yield. Why? I actually don't know. I don't know that I really care. I'm trusting the people who sat hard and thought about the syntax and how it confuses people or not. So good. I'm happy to see the preview versions in play. Okay. Some other JEPs in Java 13. Switch expressions, which we just talked about. Remember, this is still in preview. It changed but didn't get done solid. And generally, when you've just changed the spelling of something, it probably means you should do another preview just to make sure so that you don't change it again. We talked about text blocks. Those are the two things that actually affect how you code. Dynamic CDS archives. Those are really cool, as I said. And now you can take your own application, create CDS archives to make it start up faster, and saves time on class loading and parsing and verification, and etc. ZGC has improvements in it. It's still experimental, but you know, now it can do a little more elasticity for container environments, uncommit memory it doesn't use. And then under the hood, there's been a major re-implementation of the socket API, which is a really good thing. The API itself did not change, but the implementation has changed, and this is probably something that's been 15 years in the making, and finally, there's a new and hopefully better implementation. Remember, this is only about 3 weeks old, so we'll find out the hard way. Okay. So a couple of notes about future things, and then I want to talk about how you use all this stuff. So there are a couple of projects down the pipe. Which version of Java it'll come in, we don't know. Some of these were supposed to be in Java 9. So, you know, it's a good thing we don't tie the version to the feature anymore. Project Valhalla is focused on a bunch of things, but primarily on performance and primitives and being able to flatten things. You've probably heard of value types. The problem we can describe is we can't spell collections of primitives today, and we really want to, because the overhead and the topology of having non-primitive objects in collections, when we really want just a collection of ints or doubles or something, is pretty high. So the idea in value types, or whatever they're going to be called, like for example, inline class might be the spelling for them, is that it codes like a class, but works like a primitive. So you code it in the syntax you're probably used to, like a class with fields and structures and etc. But they're final in the sense that you don't build hierarchy trees under them. And there's some limitations. For example, they can't have identity. And at least in current design, they're meant to be immutable. So you can't modify it. You can replace the whole thing, but you can't kind of modify a field at a time. Can't implement an interface and encapsulation, etc. But you will be able to put them into generic statements so that they'll be value. And technically, you can do a value that's an int or a value that's a tuple, X, Y, Z, that kind of stuff. And we'll see things with arrays of these things that scan fast, match the way hardware does stuff, etc. The other project that seems to be hot and in the works is Project Loom, which is very lightweight threads on top of Java, less memory, less overhead, but same semantics, so that existing multi-threaded code will be able to use it. But think hundreds of thousands or millions of actor-like threads, but threads rather than actors. So these are two coming down the pipe, and we'll see how they do. You can track the projects online. Now at this point, what I'd like to do is talk a little about OpenJDK as a whole, not just the project, but everything around it and what you probably end up using. How many of you here are running a paid-for Oracle subscription JVM? A few. And there are probably going to be more, because it's out there, it's a good JVM, Oracle needs money to pay for all this development. But OpenJDK is probably where most people will end up. And the thing to remember about OpenJDK is a source code project. What OpenJDK produces as a project is source code for a release. We end up with an agreement of what OpenJDK 8 update 222 or 13.01 mean. And it's source code, and all of you can go and build it. Go have fun. But if you actually want to end up running stuff, same as you don't probably go build your own Linux kernel every time, you probably end up looking for some distribution with some credibility, a place you trust, a place you're used to going to. And basically any binary you get will come from some sort of distro. If it's your own distro, that's fine, trust yourself. But when you build it, it'll say Java version dash internal, which it should, because it just came from you. Hopefully you don't give it to somebody else. Or if you give it to somebody else, they'll see dash internal and know to be kind of suspicious of it. When you see the ones with the version strings that seem to say something serious, it usually means that somebody actually put work into it, built it, tested it, got kicked around some. And there are many distros out there. Some of them, quite a few, are very well built, very well tested. Some of them, not as much. To give you a specific example, this is a thread I started a few months ago when I found out that 10 million people have been using something that was calling itself Java 8 Update 222. 222. Nope, 212, sorry. Java 8 Update 212. But it was missing all the security updates in 212. And in that release, there was a CVSS 9.0 and two 8.1s. And 10 million people were running exposed because Docker run Java-version reported the wrong version. The default Docker JVM ended up using one of those. So the highlight there is there's good OpenJDK out there. We make one, a bunch of other people make one. Go check where you're getting your stuff, make sure it's good. Don't worry too much if you find a good one, but don't just loosey-goosey try that. You don't want to be one of those 10 million because the hackers have your keys. Here are some names. Zulu is the one we build, but there's also Corretto and Dragonwell and Liberica and Adopt, and some of the distros like Red Hat have very good tested ones, and some of them don't. Okay. So you have plenty of choice, but with the few minutes I have, I'm going to talk about one of the choices, which is Zulu. So what is Zulu? Zulu is basically the longest standing, widest distribution of OpenJDK. It's a curated distro of the OpenJDK source code built for Mac OS and Windows and all the Linuxes, including Alpine Linux with native muzzle builds. It does 32-bit and 64-bit. It does ARM 32-bit and 64-bit. It's basically got all the packages you want. And when I say curated, we take into account what people actually do and run into, and have added the things that are missing. So for example, we have JDKs, we have JREs. We now package JDKs with OpenJFX in them. And there's a very ironic reason that we put OpenJFX inside a JDK now. Most people think OpenJFX is really cool. It is really cool. Use graphics and all that. But how many of you have written a JFX application? A handful. How many of you have used a pair class? Just pair, a tuple, somewhere in your code. How many of you know if the pair class came from javafx.util.pair? Because that's the number one reason we have for people asking for OpenJFX, for JavaFX. It's not that they need a JavaFX thing, is they just happen to use a pair class. And since Oracle Java 8 had JavaFX in it, all the IDs auto-completed to that one. So there's a lot of code out there that just depends on JavaFX because of one class. And there are a few other classes, so we put JavaFX in there just so things will work without changing, right? Another couple of examples is, how many of you played with Java Flight Recorder? If you haven't, I highly recommend you do, because Oracle did open source Java Flight Recorder in Java 11. All the OpenJDK 11s have it, and Mission Control is a beautiful tool. Once you start using it, it's amazing what you can see inside. But it wasn't available on Java 8. So we actually backported Java Flight Recorder to Zulu 8 in OpenJDK. We've actually upstreamed the changes to OpenJDK 8. It's sitting in a nursery kind of repo, and eventually, I hope in a quarter or two, will show up on all the OpenJDK 8s. But if you want an OpenJDK 8 that you download right now and has all these tools working on it, guess which one it is? It's Zulu. And the general idea is we basically are curating a good JDK that we think is the normal default one people would like to use. Another key thing that we've done, and that we're sort of, I'm not sure if we're announcing here or we announced a couple weeks ago, but let's call it an announcement, is we've added a notion of what we call MTS releases, midterm support releases. And to explain why, let me talk about the need for version overlap. So every time we come out with a major Java version, it takes a while to stabilize. How many of you are running Java 13 in production again? It's 3 weeks old. You're probably doing the right thing, right? So it takes a while. And a while might vary, but if we look at history, there's been a lot of bugs post-GA on releases. Java 8 had this many bugs fixed in the first 17 months. More importantly, even if you start the clock 6 months after GA, there were still this many bugs fixed after that point. Java 8 reached its rock-solid good for production probably a year to 14 months into its life after GA. That's normal. And so far, given the hands that were shown before, we don't actually have good data past Java 8 for how people adopt and whether it's production ready. Java 11 now is a year and 3 weeks old. It's just entering that maturity phase of actually being pretty solid. We're hoping we've gotten all the feedback, although since the adoption was slower than before, we may not have had as much feedback on bugs, so it might take a little longer to stabilize, but it will get there. The thing is, as it's getting there, you need to run things in production. And those things in production are not going to be the 3-week-old or 2-month-old releases. So until the new GA thing runs, you need to run something. And when there are updates needed for security reasons, for critical fixes, for other things, you need to update not just the latest GA, but the other things. A week from today, there will be, a week from yesterday actually, there will be a Java 13.01. It'll have a security fix of it, and you'll find out what it is a week from now, right? How many of you are going to switch to the 4-week-old Java 13 for that security fix? Probably very few. because the class file version changed, and the things that parse the class files don't work, so you have to update them, etc. Most likely, you're going to want a security fix for a previous version. Okay, and the same goes for other bug fixes. If we look at the history of overlaps, this is what things used to look like under Sun and early under Oracle. So between Java 5, when Java 5 came out, or when Java 6 came out, we had a 3-year overlap where Java 5 was still being updated for free while Java 6 was maturing. That's a huge amount of time. Then we had from 6 to 7, we had about 20 months. From Java 7 to 8, we had about 13 or 14 months. That was the last longer than a year update site we had, but you guys haven't transitioned the next one. From 8 to 11, there were 4 months of free updates from Oracle. The community did pick up on that and did 11. And we're now in this place where there are no updates for these things in the middle. Now, the problem that we see here is that they're very interesting feature releases, but at the same time, since you don't have overlap, you might not take them to production. And if you don't take them to production, we don't get feedback for those preview releases, and then we don't know how to fix the spelling, right? The idea in an MTS release is to fill in the gaps. So this is the Zulu roadmap on top of that. This is just matching. You know, everything's the same. LTS is LTS, feature is feature. But we're adding these MTS releases. MTS stands for midterm support. And the purpose of these midterm support is not to support you for 8 years on this release. We don't want to do that. But we will keep updating those for free on the community Zulu releases until 18 months after the next LTS comes out. So you have a soft landing into an LTS. What that means is you can take Java 13 to production when you feel ready, and it won't stop getting updates until there'll be something to move to. You're not going to be stuck with a 3-week-old or 2-month-old thing to move to or move back without an update. And we're hoping that that will change how people take the actual feature releases into production, because now there's a vehicle to do that. So that's going to be available, that is available for free with Zulu. The first MTS release we are doing is Java 13, so that's young. It just came out, but we will keep updating this. You can see that we'll do the same to Java 15. We're not going to do it every 6 months, just every year. And you might also notice that Java 15 support length is shorter than Java 13, because both will end 18 months after Java 17 comes out. The reason is we're giving you 18 months into the next LTS. You will need to move to the LTS, but you have time. Hopefully the LTS is fully mature at the time when you have to get off of this one. Okay, so that was the free stuff. We do a lot of free stuff. I get to say one thing or a couple of things about other non-free stuff. Zulu Enterprise is a commercial product. We sell support. It's Zulu with commercial support. It does releases, MTS, LTS updates that are fit for production use with urgent security updates available when you need them beyond what other people do. We include all the indemnification and non-contamination, and it's used pretty widely. To give you a feel for how widely, here's a few widely used cases. These are all people running it. But in addition, just for context here, the entirety of Microsoft Azure runs on Zulu, all these versions. And you might have heard of an announcement here called Azure Spring Cloud. Azure Spring Cloud runs entirely on Zulu, 7, 8, 11, or 13 today. So if you're using Spring Cloud, Azure Spring Cloud, you'll be using this. It's also got all these releases. We don't commercially support the short 6 months ones in the middle, and we do 24/7 support. To summarize, well, there's a lot to catch up on. You've got Java 8, you're using it, then there's 9 and 10 and 11 and 12 and 13. And we're going to have things going forward and going forward. These are LTSs. And we've added an MTS in the middle. And with that, we'll see if we have any time for Q&A. I think we're 1 minute over. How are we on time from a transition? No time? Okay, I'll be happy to take questions outside because we need to clear the room for the next speaker, but thank you, everybody.